Chapter 1, Introduction. Quality is not an act, it is a habit. Aristotle. Key questions addressed in this chapter. Number 1. How does the PDCA framework drive continuous business success? Number 2. What are the key steps of PDCA, and why is each crucial for problem solving? Number 3. How can adopting PDCA improve daily operations and decision-making in modern businesses? What to expect in this chapter? 1. An overview of the PDCA cycle with a success story. 2. A brief history of the PDCA method, its evolution in business practices, and the SMART PDCA-SDCA Cycle innovative technique. 3. Discover the SMART PDCA-SDCA Cycle and unlock a sustainable approach to measurable progress and process mastery. 4. Highlight the advantages of using the PDCA cycle in organizations for ongoing success. 5. Real-world application and examples of how Indian businesses effectively apply PDCA to drive improvements and solve problems. 6. An outline of the book's chapters to learn from each section. Understanding PDCA, a story for success. In the late 1990s, the Pearl River School District in New York was a source of pride for its community. Parents sent their children there with high hopes for their future, and teachers worked tirelessly to shape young minds. Despite their dedication, however, the district began facing severe challenges. School test scores were falling, classrooms felt chaotic, and student engagement was declining trend. For the teachers and administrators, this was frustrating. They were doing their best, introducing new initiatives and strategies, but nothing seemed to stick. No consistency or structure was guiding their efforts. They tried everything they could think of, yet they couldn't figure out where they were going wrong. Meanwhile, parents lost trust in the system and worried about their children's future. What's happening to our district? They ask. How can we fix this? The district's leadership understood they needed a solution, not just a band-aid. They couldn't keep reacting to problems as they appeared, they required a systematic way to improve. This was when they realized their core issue wasn't a lack of passion or ideas but structure. They needed a framework to bring order and consistency to their efforts, which could guide them in fixing problems and preventing them from arising. That's when they discovered the PDCA, a Plan Do Check Act, cycle, also known as the Deming cycle. PDCA provided a continual improvement process based on the scientific method, planning a change, implementing it, evaluating the results, and then acting on what was learned. Let's break it down. Planning involves identifying the problem and planning a change. Doing is about implementing the plan, checking is evaluating the results, and acting is making necessary adjustments based on the evaluation. It was straightforward but impactful, offering the district a structured approach to its problems. The first phase of PDCA is planning, and this began with the district asking tough questions. What did they need? Where were their current systems failing, and how could they be improved? School leaders gathered data from various sources, test scores, teacher evaluations, student feedback, and parent concerns. As they delved into the information, the problems became more apparent. The curriculum lacked consistency across schools, and teachers weren't receiving the support needed to reach their goals. Student services were fragmented, leaving the most vulnerable children behind. Armed with this input, the district crafted a strategic plan with clear goals for improvement. They focused on 6 key areas where the PDCA model could help: strategic planning, needs analysis, curriculum design and delivery, staff goal setting and evaluation, student services, and classroom instruction. With these priorities in place, they were ready to move on to the next phase. The doing phase was where the district put its plans into action. However, they didn't implement sweeping changes all at once. Instead, they worked methodically, step by step. For example, in curriculum design, they set up teams of teachers to review the existing curriculum, identify gaps, and recommend improvements. They didn't impose a new curriculum overnight but began with a pilot program in a few schools, monitoring how it performed in real classrooms. The district introduced clear, consistent performance standards for teachers, but teachers still needed to realize what was expected. They were given goals aligned with the district's strategic plan and supported by professional development to help them meet those goals. In classrooms, teachers focused on improving instruction by collaborating and gathering student feedback. PDCA allowed them to try innovative approaches while ensuring that they learned from their experiences. Once these changes were underway, the district entered the checking phase. The district's rigorous evaluation went beyond simply checking off boxes, striving to find actual results and measure the success of each initiative. They monitored student test scores, not just as ultimate outcomes, but as tools for understanding deeper issues. Were the changes to the curriculum helping students grasp core concepts more effectively? Were teachers receiving enough support to meet their goals? The results were encouraging, but could have been better. Some schools showed marked improvements, while others continued to struggle. However, this didn't discourage the district. Instead, it reaffirmed their commitment to continual improvement. They didn't see setbacks as failures, but as opportunities to gain experience and refine their approach. In the acting phase, the district solidified its commitment to long-term success. After analyzing the results from the checking phase, adjustments were made where needed. In schools where the new curriculum was working, it was expanded district-wide. In schools where teachers needed more support, it increased training and provided added resources. It used data not to criticize, but to understand where it could do better. Student services also saw improvements. By regularly reviewing feedback from students and parents, the district tailored services more effectively to address the specific needs of each student, particularly those who had been falling through the cracks. As Pearl River School District fully embraced PDCA, the results became apparent. Test scores rose steadily, classrooms became more engaging, and teachers felt empowered to do their best work. Parents noticed these changes as their children began thriving in ways they hadn't seen before. In 2001, the district's efforts were nationally recognized when it received the prestigious Malcolm Baldrige National Quality Award. This award celebrated its commitment to continual improvement and excellence in education. But for Pearl River, the award wasn't the goal, it was just a milestone in its ongoing success. The district's story is a powerful example of how the PDCA cycle can lead to real, lasting change. By taking a systematic, thoughtful approach to improvement, they overcame their challenges and created a brighter future for their students, teachers, and the entire community. It's a reminder that success isn't a destination, it's a continuous journey. With PDCA as its guide, the Pearl River School District grew more robust with each improvement cycle. The historical context of PDCA in 1939, Dr. Walter A. Shohart integrated the scientific method with continuous improvement by organizing three key steps: specification, production, and inspection in a straight line, Shohart's cycle. He later suggests that these steps should follow a circular pattern rather than a straight line, reflecting the continuous nature of the mass production process. This approach involves forming a hypothesis, conducting experiments, and testing the results. Together, these three steps: specification, production, and inspection form a continuous improvement cycle. In 1950, W. Edwards Deming modified Shohart's cycle during an 8-day seminar on statistical quality control (SQC) for managers and engineers at the Japanese Union of Scientists and Engineers (JUSE). Shohart's three-step cycle: specification, production, inspection was transformed by Deming into a four-step process: 1. Design, 2. Produce, 3. Sell, and 4. Redesign through market research. Prizing continuous interaction among design, production, sales, and redesign through market research in improving product quality and service. In Japan, this cycle became recognized as the Deming wheel. Masaroki Imai's account of the Japanese executive's adaptation of the Deming wheel from the 1950 JUSE seminar into the Plan Do Check Act (PDCA) cycle in 1951, as depicted in Figure 3.1, is a significant milestone in the history of quality management. Imai's insights, shared in his 1986 book Kaizen, The Key to Japan's Competitive Success, underscore the evolution of the PDCA cycle. He draws a clear parallel between the Deming wheel and the PDCA cycle, equating design with plan, production with do, sales with check, and redesign through market research with act. The PDCA cycle is crucial in quality management. It is primarily focused on preventing error recurrence by setting and refining standards. Before the PDCA cycle can be effectively implemented, it is essential to stabilize the existing standards. This stabilization process is often called the SDCA, Standardized Do Check Act, cycle. Question: what is the difference between PDCA and SDCA? The PDCA cycle is used for process improvement, while the SDCA cycle plays a crucial role in preventing or maintaining the deterioration of already improved processes. Once modifications are made, the SDCA cycle maintains and standardizes processes. This stabilization is a necessary step before moving on to further improvements through PDCA cycles. The first PDCA cycle, developed to address shop floor problems and prevent recurrence, is a robust model with many practical applications. Whether it's quality improvement, process enhancement, product design and development, service offerings, educational curricula, or healthcare, the PDCA cycle provides a comprehensive framework for understanding what needs to be done and the current position within the cycle. In 1985, Kaoru Ishikawa modified the PDCA model by adding elements to the plan and do steps. In his 4-day seminars in 1980, Deming presented the PDCA version, arguing that the plan, do, check, and act version is inaccurate for Western audiences because the English word check means to hold back. In 1986, Deming reintroduced the Showhart cycle, which came directly from the 1950 version, Deming wheel. In 1993, Deming again modified the PDCA cycle and called it the Showhart cycle for learning and improvement of a product or a process, the PDCA cycle. In 1994, Langley, Nolan, and Nolan refined the improvement cycle, renaming it the PDCA cycle. The use of the word study in the third phase highlights the goal of this step, to build new knowledge. It does not confirm that a change led to improvement during a single test. It is also essential to predict whether the change will produce comparable results under varying conditions in the future. They introduced 3 fundamental questions to enhance the PDCA cycle. 1. What are we trying to accomplish? 2. How will we know that a change is an improvement? 3. What changes can we make that will lead to improvement? Langley, Moen, Nolan, Norman, and Provost combined the 3 fundamental questions with the PDCA cycle to create the API model for improvement foundation. These questions define the goal, measures, and potential changes. A set of 72 change concepts is provided to guide the use of the PDCA cycle for developing, testing, implementing, and spreading modifications that lead to improvement. This model can enhance organizational processes, products, and services and improve personal endeavors. It aims to balance the motivation for taking action with prizing thoughtful analysis before acting. As part of the ISO 9001 quality management system, the PDCA cycle is a versatile tool that can be applied to all organizational processes. Figure 9 in the book demonstrates how ISO 9001 clauses 4 to 10 can be aligned with the PDCA cycle, highlighting its adaptability and relevance across various contexts. The ISO PDCA cycle can be briefly described as follows. Plan to establish the objectives of the system and its processes, as well as the resources needed to deliver results under the customer's requirements and the organization's policies, and identify and address risks and opportunities. Do, implement what was planned. Check, monitor and, where applicable, measure processes and the resulting products and services against policies, objectives, requirements, and planned activities, and report the results. Act, take actions to improve performance, as necessary. SMART PDCA-SDCA Cycle. The author recommends integrating the PDCA, Plan Do Check Act, and SDCA, Standardized Do Check Act, cycles to achieve organizational goals effectively. These cycles were implemented 3 to 4 times yearly for the best results. To apply the SMART PDCA-SDCA cycle, 3 essential prerequisites, known as the 3 Cs, should be met. 1. The team should be comfortable with discomfort during the SMART PDCA-SDCA cycle. 2. Consistency should be prioritized over perfection. 3. Confidence from senior management must be established as a critical support factor. An example of the SMART PDCA-SDCA cycle can be seen in a manufacturing or pharmaceutical company aiming to reduce internal quality ppm/dpmo by 50% from the current level of 1,000 ppm/dpmo within 1 year. Specific, focused on reducing internal quality ppm/dpmo. Measurable, a targeted reduction of 50%. Achievable. This target is workable, as a Six Sigma process can achieve 3.4 ppm DPMO. Realistic. A 50% reduction is practical, though complete elimination is not. Time-bound, set to be completed within 1 year. SMART PDCA-SDCA strategy 03 or 4 cycles to achieve the objective. Strategy number 1, 3 SMART PDCA-SDCA cycles within 1 year. PDCA cycle number 1, 3 months. SDCA cycle number 1, 1 month. PDCA cycle number 2, 3 months. SDCA cycle number 2, 1 month. PDCA cycle number 3, 3 months. SDCA cycle number 3, 1 month. Strategy #2 for SMART PDCA-SDCA cycles within 1 year. PDCA cycle number 1, 2 months. SDCA cycle number 1, 1 month. PDCA cycle number 2, 2 months. SDCA cycle number 2, 1 month. PDCA cycle number 3, 2 months. #SDCA cycle 3, 1 month. PDCA cycle number 4, 2 months. SDCA cycle number 4, 1 month. How is the SMART PDCA-SDCA cycle implemented to achieve ongoing success? PDCA cycle 1. Plan phase. The plan phase, the PDCA cycle's cornerstone, is where the problem is thoroughly analyzed and a comprehensive strategy is meticulously crafted. This phase sets the direction for the entire cycle, making it a critical starting point for any improvement initiative. 1. Define the problem relative to ideal versus current. The gap between the ideal quality level, 0 defects, and the current state, 1000 ppm, must be clearly defined. Internal defect reports, customer feedback, and production data are analyzed to understand the areas causing the most defects. 2. Gemba walk hypothesis testing. A Gemba walk observes processes on the shop floor and forms hypotheses about potential root causes, such as equipment calibration issues, operator errors, or material inconsistencies. 3. Break down the problem using the 80-20th rule. The Pareto principle applies to identify the 20% of defect types causing 80% of the internal ppm issues. This prioritization ensures that efforts are focused on where they will have the most significant impact. 4. Set SMART goals and targets. A specific, measurable, achievable, realistic, and time-bound SMART goal will reduce internal quality ppm from 1000 to 500 within 1 year. 5. Conduct root cause analysis, RCA. Tools like fishbone diagrams, 5Y, or failure mode and effects analysis, FMEA, are used to uncover the underlying causes of defects. 6. Develop an implementation plan. A detailed plan addresses the identified root causes. Actions include upgrading equipment, refining operator training, and improving quality control checks. 7. Create a follow-up plan. The follow-up plan is established to monitor the implementation's progress, assign responsibilities, and set review dates. 8. Secure PDCA approval from management. Senior management approval is sought to ensure alignment and support. Resources, budgets, and timelines are confirmed. Do phase. In the do phase, the implementation plan is executed. Implementation of the plan, actions are put into motion. For example, new equipment settings are calibrated. Revised training sessions are delivered to operators. Enhanced quality inspection protocols are deployed. Materials from alternate suppliers are tested. The focus is on maintaining consistency and gathering data throughout the implementation process. Check phase. The check phase verifies whether the implemented changes achieve the desired outcomes. Verification of results. Quality control teams regularly measure ppm levels. Data is compared against baseline levels, 1000 ppm, and the target, 500 ppm. Any deviations are carefully analyzed to determine if adjustments are needed. Act phase. The act phase focuses on institutionalizing the improvements and refining the processes. Adapt, adjust, and update SOPs, standard operating procedures, SOPs, are updated to reflect the successful changes. Lessons learned are documented, and adjustments are made to ensure long-term sustainability. SDCA Cycle 1. Standardizing and maintaining improvements. Once the initial PDCA cycle is completed, the SDCA Standardized Do Check Act cycle is employed to sustain the improvements and integrate them into daily operations. Standardize phase. Standardize the improvement. New best practices are standardized across the manufacturing process. Work instructions, quality inspection protocols, and operator manuals are updated to reflect the improvements. Do phase. Maintain the improved process. Regular audits and inspections are conducted to ensure compliance with the updated standards. Operators are continuously trained to reinforce the improved processes. Check phase. Calculate process capability. Statistical tools, such as process capability indices, CP and CPK, evaluate the consistency and stability of the improved processes. Act phase. Take action to improve process capability. Further adjustments are made if the process capability falls short of expectations. Continuous monitoring ensures that any deviations are promptly addressed. Repeating the PDCA-SDCA cycles for sustained growth. The PDCA-SDCA cycles are repeated 3 to 4 times a year. Each cycle builds upon the previous one, ensuring continuous improvement and sustained growth. 1. In the second cycle, additional root causes are addressed, focusing on secondary contributors to defects. 2. The third cycle may concentrate on cross-departmental collaboration to tackle systemic issues. 3. By the fourth cycle, the organization transitions into a culture of continuous improvement, where proactive problem-solving becomes embedded in daily operations. Practical implementation. A case in manufacturing. A mid-sized automotive parts manufacturing company followed this roadmap to reduce internal quality ppm from 1,000 to 500. Cycle 1. Tackling major defects. During the first cycle, a Gemba walk revealed that misalignment in assembly equipment caused 60% of defects. Immediate actions included recalibrating the machinery and retraining operators. Within 3 months, ppm was reduced by 20%. Cycle 2. Enhancing quality inspections. The second cycle focused on strengthening the quality control system. Advanced inspection tools were introduced, and defective trends were analyzed in real time. Another 15% reduction in ppm was achieved. Cycle 3. Optimizing material supply. In the third cycle, material inconsistencies were identified as a significant issue. Collaboration with suppliers led to stricter material quality standards. This resulted in a further 10% reduction. Cycle 4. Institutionalizing improvements. In the last cycle, all improvements were standardized through updated SOPs and frequent audits. The internal ppm reached the target of 500, completing the 1-year goal. Conclusion. The SMART PDCA-SDCA cycle is a structured and adaptive framework designed to drive continuous improvement and sustain success across processes. By integrating the principles of problem-solving and standardization, this cycle ensures organizations can achieve both short-term goals and long-term growth. Its implementation is carried out systematically, balancing meticulous planning, effective execution, and rigorous standardization. The process begins with the SMART PDCA cycle, where clear and actionable objectives are set using the SMART criteria: specific, measurable, achievable, realistic, and time-bound. During the plan phase, problems are defined, root causes are analyzed, and actionable solutions are designed. The do phase ensures these solutions are implemented in a controlled manner. Progress is monitored in the check phase, verifying outcomes against the objectives. Finally, successful improvements are institutionalized in the act phase, and any necessary adjustments are made to refine the process further. Once improvements are implemented, the SDCA cycle is employed to sustain these gains. This phase focuses on standardizing the improved practices to ensure consistency and reliability. Processes are regularly monitored to maintain efficiency, and further opportunities for refinement are identified. This iterative approach creates a continual learning and adaptation culture, enabling teams to align their efforts with organizational goals. The true strength of the SMART PDCA-SDCA cycle lies in its adaptability. It can apply to diverse industries and processes, from manufacturing to service delivery. By focusing on systematic improvements and embracing a culture of accountability and innovation, this methodology ensures that organizations can navigate challenges, seize opportunities, and achieve sustained success in an ever-changing environment.